Hi class, Miss Meg here. Thanks for tuning into the video this week. Like we said in class, these videos are mandatory for you to watch. You do need to take notes on them, so thank you for tuning in. I hope you're having a great weekend. This video should only be about 6 to 7 minutes in length, so it shouldn't be too long. But without further ado, let's just jump into the notes. Alright, so last week your video that you took notes on was point signs and planes definitions and labeling. Today we're going to be talking about measuring segment length. So, these are a new set of notes, so turn the page in your Spiral notebook and label the top Unit 1, Section 1.3 Segment Addition Postulate. In the top right-hand corner, you're going to write a number 2 to note these are your second set of notes. Listed below are your objectives for today. You might want to pause the slide here at this point because I'm not going to stay here for very long. What you should know is that we will be going over the first 3 bullets on this slide, and the 4th bullet we'll be talking about more in class. So the first part of the notes are going to be vocabulary words. We're going to talk about 6 vocabulary words first, and then we'll move into a couple numerical examples. So first 3 vocabulary words are listed on the slide: coordinate, distance, and segment length. And what's really important to note about these vocabulary words is length will always be positive. So we're going to talk about absolute value and the importance of always taking the absolute value. But basically what you should remember is that length will always be positive and will never be negative. And remember, pause the slide if you need extra time. Segment addition postulate. What you want to write is, if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. And we're going to go over a numerical example of this, so if it doesn't make total sense right now, that's okay. We will be going over through a couple of numerical examples. Congruency. Basically, if 2 segments have the same length, they are considered congruent. And segment midpoints. So midpoint should be a familiar term. You probably used it in Algebra 1 and middle school math a lot. Basically, it's the point at the center of a segment. And segment bisector is a term that you might not be as familiar with, but basically a segment bisector is a more descriptive term of something that intersects a segment at its midpoint. So what a segment bisector does is that it cuts a segment in half. Okay, so that's it for vocabulary words. We are going to talk about finding segment length. So these 4 steps listed on the slide should be pretty self-explanatory once we actually get into an example, but the general gist of finding segment length is you have to find a coordinate, find a second coordinate, take the difference between the 2 coordinates, and then find the absolute value of those 2, of the difference. So our first example is on the screen. So we have a number line with 4 points, A, B, C, and D. And what we will need to find is the length of AB. So let's move to my board so I can show you some examples. So we want to find the length of AB. And we knew that A was at the coordinate -4. And B was at the coordinate -1. And you do want to write this example down in your notes, so just title it Example 1. Okay, Example 1. So what we want to do is we want to take the first coordinate, -4, and we want to subtract from it the second coordinate, or -1. If you are not so good with subtracting and adding negative numbers, you want to come to me for extra tutorials so that you can get a better grasp on what it is to add and subtract negative numbers. Okay, so -4, if we subtract -1 from -4, we're going to get -3. And like I said, distance can never be negative, so we want to do as our last step is to take the absolute value. And what we get, and remember, absolute value is just the distance from 0, so -3 is exactly 3 units from 0. So the length of AB is going to be 3 units. Okay, it's important for you to write units because we aren't dealing with a specific unit of measurement. But I do ask that in this class you always, always, always give me some kind of units, whether that is feet, inches, centimeters, or just units. Okay, back to the slides. And you can find the length of AC and BD on your own. We won't have time for it in this video, but using that same process, you should find the length of AC and BD. Okay, and here's a little bit more difficult example where we're not using a number line, but instead we're given an actual segment, and we're given segment PQ and R. All right, so P is right here, Q right here, and R right there. And we know that PQ is 7, and we know that QR is 10. So what we're going to do is always, always, always label your diagram. So we know that PQ is 7 and QR is 10. And what we're trying to find is this length PR. So what we're going to do is we're going to set up our segment addition postulate, which says PQ plus QR equals PR. And then from this segment, we're going to substitute what we know. We know that PQ is equal to 7, and we know QR is equal to 10. When we simplify the left side of that equation, we get 17 equals PR. And we know that that is going to be our answer. So PR is 17 units. Oh, and you want to make sure you label this example 2. All right. And then this is actually going to be example 3, so don't pay attention to that slide. We're going to label it example 3. And this is a slightly more difficult example, whereas the last one involved only numbers. This example is going to involve some algebra. So just like in that last example where we were given a segment, we're going to be given segment ST and TU, so ST and TU. And we know that segment ST is equal to 3x plus 3, and we know that TU is equal to 2x plus 9. So, and we also know that SU is equal to 32 units. So what we're going to do is we're going to set up a similar equation to the last one we just did. We're going to say ST plus TU equals SU. And then using what we know from the problem, we're going to substitute. We know ST is equal to 3x plus 3, so I'm going to write 3x plus 3. We know TU is equal to 2x plus 9, so I'm going to write 2x plus 9. And then I know that SU is 32. So all I've done is I've taken the information I know in the problem and I've plugged it into my equation. The next steps are all algebra. So you're going to combine your like terms. I'm just going to circle and underline my like terms. And I get 3x plus 2x is 5x. And I get 3 plus 9 is 12. So I'm left with 5x equals 32. The next step in the algebra is to subtract 12 from both sides. And you get 5x equals 20. Right, then we're going to divide by 5, and we get x equals 4. This example is important because what you need to do is you always need to read the problem. So if we look back at the problem, we would see that it asks us to find ST and TU, not X. So we are not done yet. Our last step in this process is to plug back in. So what I'm going to do is I'm going to plug back in 4 to my equation. So I'm going to say 3 times 4 plus 3. And I need to simplify this right side. So I get that ST is equal to 12 plus 3, or 15. And then I'm going to do the same thing with TU, and I'm going to plug 4 back into my expression. So I get 2 times 4 plus 9, and I get 8 plus 9 equals 17. To check, we would say that 15 plus 17 needs to equal 32. So the sum of our parts must equal our whole. And if we simplify this left side, we get that 32 equals 32. And we are right. So your final solutions would be ST equals 15 units and TU equals 17 units. Okay, so that's it for this video. Remember to tune into the next video for this weekend. So you do have 2 videos you have to watch this weekend. So this was the first video. The next video is going to be about angle addition. So be sure to click on Unit 1, Section 1.4, Angle Addition next.